This video will be on finding solutions in a restricted domain without a calculator. So let f of x equal 3 plus 2 cosine x and g of x equal 2. In the xy plane, what are the x coordinates of the points of intersection of the graph of f and g from 0 to 2 pi? So this is exactly the same setup that we looked at before, but you are expected to set up the equation yourself from the information given. So we have f of x is equal to g of x. F of x is 3 plus 2 cosine x. And then g of x is just 2. Okay, so we want to find when does f of x, or when do f of x and g of x intersect, and we set two expressions equal to one another in order to find where this happens. So again, we want to isolate the trig, so I'm going to subtract 3 from both sides. So I'm left with 2 cosine x, which is negative 1. And then we'll divide both sides by 2, so I get cosine of x is equal to negative 1/2. Now it's non-calculator, so it's going to have to be a standard angle on the unit circle. So cosine is negative in quadrants 2 and 3, and it's 1/2, so it's going to be relatively close to the y-axis. And the two angles for this are going to be x equals 2 pi over 3 and 4 pi over 3. Pretty standard. All right, the next one, the function g is given by g of x is equal to 3 minus 4 sine squared x. What are the zeros of g on the interval from 0 to 2 pi? So now we just want to know, okay, when does this cross the x-axis? All right, so if you think about a sinusoidal curve, this one is sine. I know I have some transformations, but just to get a visual, it's going to look something like this, and we want to find out, okay, where are the x-intercepts, or where are the zeros, the roots, the solutions, and how do you find those? It's when y is equal to 0, or in this case, g of x. So we're going to set g of x equal to 0. Same thing, we'll isolate the trig. So we're going to subtract 3 from both sides, and then divide by negative 4. So we get 3 over 4. Now I have this sine squared, so in order to get it down to a degree 1, we'll take the square root of both sides. So on the left side, I'm left with sine x, and then on the right side, properties of radicals, we'll have radical 3 over radical 4, and radical 4 will just be 2. So I end up with root 3 over 2. On the unit circle, sine is positive in quadrants 1 and 2, and it's going to be pretty far from the x-axis, almost as far as possible. So that means we have x. Oh, I made a big mistake. Big mistake. So I need to go back to where I took the square root. And there should be a plus or minus. Almost forgot about it. And then I need to continue that through here. And the reason why I knew that is because, okay, I have sine squared, which that also tells me I should have more solutions than 2. I should be doubling up. And then I got to my unit circle, and I'm like, okay, I only have 2 solutions, so something's wrong. So I forgot the plus or minus. So now I went when root 3 over 2 is not only positive, but also negative. So we'll go in both directions. And this will be the family of 3s. So I have x is equal to pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. And I'm not including a 2 pi k because I only want solutions from 0 to 2 pi. Okay, same thing up here. I only want solutions from 0 to 2 pi. So no 2 pi k, restricted solutions. All right, number 4, what are all the values of theta from 0 to 2 pi where cosine squared theta is equal to negative cosine theta? All right, so we'll go ahead and start solving this. Now, 90% of the time when I'm teaching this, people go, I'm like, what's the first step? They'll go straight to this. Oh, divide by negative cosine theta. Okay. If we do that, we end up getting cosine theta is equal to, negative cosine theta is equal to 1. Before we had cosine squared and then a cosine theta, but now we're just down to 1 cosine. We lost a lot of our solutions, all right? So in trig solving, you never want to divide a trig expression with another trig expression unless it's a rewrite. Like if you divide cosine by sine, you get cotangent. So you don't lose the solutions, they're just being represented a different way. But in this case, because it's cosine over cosine, I would lose solutions. So we need to try another method. Let's try adding. So we'll have cosine squared theta plus cosine theta is equal to 0. Now, if you think back to algebra, we are able to solve algebraically when we are multiplying terms that are set equal to 0. Right now I have cosine squared plus cosine. There's no way to solve these because it's not multiplicative. It's just, okay, cosine squared plus cosine. We can't set these individually equal to 0 in order to solve them. So last year, or we should have had algebra 2 last year, x squared plus x equals 0. Let's try this. If I want to solve this, I can factor out an x, and then from here, I can set each individual part equal to 0 to solve for their individual solutions. We can do the same thing here. We can factor out a cosine, so we have cosine plus 1. And now from here, I can solve each individual part in order to get all the solutions for cosine squared equals negative cosine theta. So let's start with cosine theta is equal to 0. On the unit circle, cosine theta is equal to 0 at pi over 2 and 3 pi over 2. And again, no plus pi k or anything because I only want solutions from 0 to 2 pi. And then we'll do cosine theta plus 1 equal to 0. Isolate the trig expression, I get cosine theta is equal to negative 1. On the unit circle, that will be all the way over here. Therefore, theta is equal to pi. And if you want to write it as theta equals pi over 2, comma pi, comma 3 pi over 2, you can. I think it's redundant, but you can do with that whatever you please. All right, let f of x equal 2 sine squared x and g of x equal root 3 sine x. In the xy plane, what are the x coordinates of the points of intersection of the graph of f and g for 0 to 2 pi? So points of intersection, that means we're going to set them equal to each other. So we'll have 2 sine squared x is equal to root 3 sine x. So I have a common term, sine. Again, don't divide. Get everything to one side since we're solving, and then we can factor. So we have sine of 2 squared x minus the square root of sine x is equal to 0. Greatest common factor will be sine x, so we'll factor out sine x, and then I'm left with 2 sine x minus the square root of 3. Now that we have multiplicative terms, we can go ahead and set each of these individually equal to 0 and solve for their individual solutions. So I have sine of x is equal to 0, and I also have 2 sine of x minus root 3 is equal to 0. For the first one, sine is equal to 0 at 0 and pi. So that means x is equal to 0 pi. Next one, we can add root 3. So I have 2 sine x is equal to root 3. Divide by 2, I have sine x is equal to root 3 divided by 2. On the unit circle, we will be pretty far from the x-axis. So this will be pi over 3 and 2 pi over 3. All right, the next one will be solving with a calculator. All right, hope this helps.